Hey, what's up everyone, and welcome to Ramiro's Lab. Today we are going to do the slider. Yes, we are hacking the slider. Basically, we're going to take the slider controller, comes with the slider. We're going to make an Arduino shield so we can actually control it from Unreal Engine. Unfortunately, it's not scalable to hack. We could hack this and use this instead, but it's not scalable. So basically, let's make one device that is going to control whatever we want, and that's is going to be, the bigger idea, to make one controller for everything else. The idea is that we can control any slider, any camera gimbal, and everything goes to this device, to Unreal Engine, and going back and forth. So we're going to use this slider. It's basically probably the cheapest that we have right now in Amazon, 179. It's the GVM motorized slider. And actually it's really good. It's anodized aluminum. I really like it better than the carbon fiber. The carbon fiber tends to bend a little bit, and since we're gonna put a lot of weight, especially we're gonna put all these camera gimbals, so I strongly recommend to use aluminum sliders or something really strong. This is what we're gonna use, and like I said, we're not gonna use this little boy. We're going to actually make our own controller. So we're going to reverse engineer the motion controller that we have over here, and we're going to replace it with the new controller that we're making with Arduino. We're going to program the Arduino sketch and Unreal Engine blueprints, and we're going to put it together. So what I said before, with this device, it has to be able to connect whatever you have, any camera slider, any controller, actually any focus assistant, anything remote control. And the best way to do it is just make your own tool. It's going to be 100% open source. You already know where we're going with this. Yeah, so this block box is going to become our controller for everything. Okay, so previously we already talked about doing this kind of things. On the MIDI controller tutorial, we tried to figure out how to use the same blueprint and connect it to whatever we're going to do on the real world, which is going to be through serial communication. So that's what we're going to do today, specifically with the camera slider. So we're going to put together the camera slider. So I took apart the camera slider, just took the motors. I can show you how it works. So the first thing that we have to do, we have to reverse engineer this little guy. Okay, so we need to know what exactly have inside this controller. Something is really cool is just the way GVM do. It's a 4-pin DIN connector. So here it is. That's the connector. And on the other side, guess what? It's a USB connector. And don't connect it to a USB is not going to be a good idea. The only thing they did, you can see the 4 connections over here. They replaced those 4 connections with the connection that goes to the DIN connector. Not the first time that I've seen repurpose USB connectors, and it's not going to be the last one. So just keep in mind, when you connect something to this port, this is not actually USB. It's just the motor, and you have 9 volts coming out from here. So don't connect any USB from this device to your computer. Okay, that's pretty much what I'm trying to say. This goes here to the motor, and I'm going to show you later how to connect everything. I have this adapter, but I have another recommendation. It's actually better than this. So we're going from this connector to, we're going from that connector to the actual controller. And this is what you see inside. We're going to reverse engineer this. We have the processor, and we have power management, that we have the motor driver. And the processor is a very basic NXP ARM Cortex M0. It's a microprocessor with 32 bits. Now the power management, this is a Chinese company, but it's a DC booster, so it has a 5 volts to 40 volts input. Right now I think we have around 9 volts. Okay, so moving on the motor driver, this is a very well-known configuration, not because I have good memory, it's just because this has been used on a lot of 3D printers. And yeah, this again going to Arduino Shield, this was part of our Arduino Shield. So what we have is the Texas Instrument drive 8711, very common, and we have 4 on ON and channels MOSFET. So going back to the stepper driver, it's a very common stepper driver. You have to connect this to N channel MOSFET, which is going to be these ones, and here you see the microcontroller sending step direction and SPI to reprogram the whole driver if you have to, or it's from 1 to 256 micro steps, which we're gonna use. That's pretty much it. That's a classic configuration. It gets really hot here. You know, I really like this design. It's not compact. It has this N channels power MOSFET. Basically, this isolate your circuit so it doesn't burn the chip. It takes minimum amount of I think 5 volts, and it can't spit out up to 12 volts or 30 volts. And this one is doing right now 9 volts. Okay. And when we did to reverse stepper motor profile, we took this pin from the microcontroller and we put on an oscilloscope. I'm not going to spend all the time showing you how to do it. I just show you screenshots so we don't have like a 5 hours tutorial, but basically it's 75% to 25%. That's without counting the time, but that's counting how much the step on and step off is doing. Time wise, at 100% is 19 microseconds. And the delta 1, which is the first part, is going to be 14 microseconds, and delta 2, the off part, is going to be 5 microseconds. That again is 75-25, and that goes around the whole spectrum on 50%, 1%. It's always the same thing. Okay, so we did the calculations, and this is pretty much what I got, and very consistent to the 75-25% that the manufacturer program on this microcontroller. So what we're going to do now, we're going to replace this controller with our own controller. So in order to do this, we have to replace it one by one, and this is what we're going to do. So we're going to replace the old microprocessor, the NXP 40 megahertz, with Arduino, which is going to be good enough. So the good thing about the 80 mega and the Arduino Uno is 54 pins, and also the 256K of flash memory. That's another good reason why to use an Arduino Mega and not an Arduino Uno, and that's pretty much the reason why we're going with 80 mega 2560 and now with the Arduino. The old power management, basically we're gonna just grab a power brick and connect it directly to the Arduino Shield. To replace the motor driver, the Texas Instrument, we are going to use, actually it's a combination. We're using an Arduino Shield, CNC Shield, which has all the capacitors basically and all the connectors to the board, and it has all these pins over here. That's where we're gonna put this little guy, the Allegro 84988, which is a driver, and actually it's a combination of drivers with the MOSFETs. Here it is, very small. It's a Chinese chip. This is very popular on the 3D printer. In the future, my idea is to replace all this stuff and make a bigger version. But right now, if you want to start playing and you want to start doing experiments, or actually works, okay, this 100% works, you can use this. But yeah, right now this is like a fallback. So this is what we're doing. We're doing from Unreal Engine to the Serial.com plugin to the Arduino to the CNC Shield with the power, with only one A4988 driver straight to the motorized slide. This is exactly what the part that we're replacing. So this is pretty much the list that I recommending for this project: the motorized slider, the Arduino Mega, CNC Shield, the driver, the USB terminals. Okay, yeah, so this is the USB terminal that I recommended. It's way better than using this thing. But anyway, whatever you have, if you have this, that's pretty much what I recommend to use. And if you have a very cheap multimeter, that's gonna help. So I highly recommend to have one anyways. So this is the list on Amazon. I'm going to leave the link on the description. Also go to the GitHub where we have all the documentation. Everything is going to be here, and the information is also right there. Right there. That's the GitHub information. Okay, now we're gonna set up our new controller. The thing with this motor, we only have to have right the order of the pins. Okay, the way it's going to be connected is that's the connection for the shield. So that's the only thing that you're not going to connect. Then you're going to connect the plus, the minus, plus, and the negative. Okay, so that's the connections. And what we're going to do is we're going to test with the two probes, and it has to go around 3.8 and 4 ohms. Connected to nothing, just so you connect the cable to the USB. Okay, but the USB is connected to nothing. It should give you around 4 ohms, and the same for the other ones too next to it. Whatever it is going to be fine if it's around that. So when you probe the plus and minus, it shouldn't show anything more than overload, and the same thing for D minus and D plus. If something it doesn't work, is because it's connected in a different way. So the idea is to match this configuration, and this configuration is going to the driver controller, and then you have to match this with the driver controller. In general, it's going to be one next to the other one. There's two ways to connect power to a CNC shield. One is connecting directly to these ports over here. The other one is connecting here, but in order to do this, you have to jump one cable because they didn't design it right. If you want to do it, if you want to connect it directly here, you have to make one hack on the pin connections and connect it to the plus. Okay, so once we go there, it's just you connect these cables. Again, they're gonna be over here, right here. Okay, next to the motor. Okay, so before we start, let's start through the setup and let's see what's going on here. One of the things that you're gonna notice is that I'm using an extra serial monitor. This is an Arduino USB serial. I'm using it just for debugging. The only problem that we have with Unreal Engine is we can use the same serial port to monitor messages. So I'm using an extra one. That's another good reason why to use the 80 mega 2560. So I'm using this one and serial 3. You can see right here. That's a DX3. So I'm using that to monitor all the messages. The other thing is we're using the Y axis for this project. You can see the jumper here. So we have the 3 jumpers. That's to have maximum resolution on steps. And on top of that, you have to enable the motor. There's a pin here on the side. It says enable and ground. So you have to jumper. I don't have another jumper, so I just use a cable and jump it. So this has to be activated in order to work. Otherwise, it's which is not a bad idea. I have it like this because it gets really hot. And I have another counter. I use it for sleep, so it doesn't get too hot. You can reactivate it on the sketch, but for now I'm just leaving it like that. And then the motor here, the motor goes stepper motor right here. So this cable is this cable, and I have it on the bench, so it's easier to program and see what's going on. Otherwise, you're gonna start doing weird things on the slider. Okay, so this is the Arduino sketch. It's a very simple program. That's why I call it Hello Stepper. The idea with this sketch is just to send 3 commands. One is for moving to the right, the other one is moving to the left, and a stop command. We're using pin 3 for step and pin 6 for direction. Again, I'm using 2 serial ports. Now, I'm not going to use right now the serial 3, but so you know what it is. When I plug this USB serial, so if you have another one, you can reactivate this and reactivate the debugging. When you receive the serial command, you're going to save it on the byte command, and depend, what it is see if it's 1, going to make 1 step, but it's going to keep moving 1 step until it receives a stop command, and the same thing on the other direction. Compile, you program, it's done. I'm loading, I'm open the serial port, I'm gonna press the 1 and send it, so it's moving clockwise, and I'm gonna send the 3 to stop it, okay, and 2 counterclockwise, right? That's pretty much it. It's very simple. That's it. It's really fast, reacts really fast. And if it's not working for you, that's why I'm making it really simple, like so you know it's working, you know this should work. And if it's not working, things that you can check is always remember to have the pin enabled, so you ground enable. The other thing you can check is the connection on the stepper motors. Of course, you have to receive power from here, so you need this extra power. You can't run without power. At least the design doesn't allow you to do that, so if nothing happens, it's probably that's it. So now we're gonna go to Unreal Engine and let's do the second part. Okay, so for this part of the tutorial, we're gonna make a little bit more complicated, but not that much. We are going to send similar commands, but we're gonna use the MIDI part. So what I did is I took the same blueprint that we did on MIDI tutorial. I pasted on channel 3. What we're gonna use is it's a similar process, but we're sending 3 bytes, and this is to test more complicated commands. So we use 3 bytes plus 2 bytes. That is going to be the line end and return. And this is very useful to figure out that the message is ending. So once you receive this, you know that the whole message it's over. And the 3 bytes that we're going to send in this case are ASCII 64, which is the add. In this case, we have a step, another step. They're all steps, but the difference between this and this is the amount of step. So in this we're going to do 1 step only. On the first rotary we're going to use 50. On the second one we're going to use 20. So we send pretty much the same commands. The only difference is how many steps per revolution. Once we have that, just make sure, like in this case, I'm on the right port. I'm gonna send everything. Okay, so let me start the communication, serial communication, and let's play from here. There you go. So I have the information here. You see it's moving 50. Every time I move it, it's moving 50. Now I'm moving the other direction. This is more fine pitch. And this is 1 step at a time. You're barely gonna see it moving, but it's moving 1 step at a time. There you go, you can see it moving a little bit. And this is going from Unreal Engine to the serial communication library to Arduino to the slider. Okay, you can download both the Arduino sketch and the Unreal Engine blueprint. Yeah, I recommend to watch the MIDI tutorial so you have a better idea what this project is, the full extent of this project. Look, I know that probably 10% of the people here on this channel is going to, or not even 10%, is going to go through this do-it-yourself stuff. That is going to be a big friction for this project. What I thought is I'm going to design a unit that it can accommodate any of these devices. You know, the idea is to make it universal. So we're going to go one by one. I already say this. And this little black box is going to become the main communication device for remote control with Unreal Engine. The idea is to reduce the friction, and anyone can use it, and you don't have to do, you know, everything by yourself. But at the same time, I'm doing it open source, so everything, all the design, all the PCB, everything is going to be open source. Ideally, we make an Arduino shield that can be repurposed for other things. Again, we're using the CNC shield. We're using it for this project, and it has nothing to do with the 3D printer or whatever. I wanted to leave it open enough so people can use it for other things. Trust me, I'm not gonna make money with this. So I'm going to try to make small runs. There are ways I can set it up. I have manufacturers in China, and again, I'm not gonna be millionaire with this. So I just rather make it really, really cheap, and everybody can use it, and make it very small runs. And if you want to do your own, you can do your own. We're going to try to get all the manufacturers that we can. I hope manufacturers can be open enough to help us with the protocol they're using and details, small details that is going to help us to make a better controller. Specifically, if you're using CAN bus communication for the focus controller, some of them are CAN bus, and it's going to be up to them. This is hard to decide, what companies we're gonna just put effort on it. But I'm not gonna do it for every company. I think it's a good idea to be open so people have options. Some companies don't like that idea, so this is an open source project if your company wants to help us. But yeah, I mean, it takes a lot of effort to actually decode these companies' protocols, especially if it's SBUS. Yeah, it would be fine if they help us. What we're moving forward to, I don't want to make an announcement right now until I have it in my hand, but we're going to start working with a new camera tracker. At least for me, it's a new camera tracker. Part of the project is to have automatic focus control from that camera tracker to Unreal Engine and have both systems in sync with that focus control. Not only the focus control, I'm not talking about encoder, I'm actually talking about something similar to what DJI is using on the new system, where with LiDAR you can know the distance and automatically you can adjust it. It's very useful in dynamic situation where you have to track all the time. I think this is going to be amazing, and I'm going to integrate everything to this black box, to this system. So keep in mind, this is not just a slider project, it has a lot of aspects. Everything is going to be connected to Unreal Engine. So again, think forward, and I'm talking to all these companies. Think forward. Thinking open is not bad. Yeah, if you're open, you're welcome. That's pretty much it. Okay, so you already know, subscribe to the channel. I mean, I don't have to tell you, but go to the Discord server. There is a lot of virtual production people on the Discord server. That next we're going to keep going with the camera gimbals and also camera tracking is coming, and I'm gonna work on this better version of this, but I just want to show you how to start working on this. Okay, everybody, thank you for getting to this point, and see you next time.